So I want to explain a circuit that combines digital and analog electronics, which is called the monostatic multivibrator. So this circuit has two NAND gates. It can be done in different ways, but I'm going to describe the one with two NAND gates. And we're going to look at the output, but part of the output comes and feeds back as to the first NAND, and the input is the other input to the first NAND. And in between the two NANDs, we have a capacitor and a resistor, and that node connects to both inputs of the NAND. So this is essentially a NOT gate. The second NAND works as a NOT gate, but in between we have an analog circuit of some kind. Now you can imagine what happens if a pulse comes in to on the input that looks like this, and assuming that the output is high in the steady state, then we have high here, and if we had high at the beginning, we had 0 out because of the NAND nature. And when we turn off the input, the output here will go high quickly to the high voltage, and that will feed into the capacitor, feed through it, and turn on this NAND. So this goes high, this will go low, and that will keep this high here for some time to come, independent of what happens at the output. So we can first see that in between here it goes up at first, but then as the charge can run up the resistor, that voltage will slowly decay away, and when it gets to halfway, this output will turn off, or actually it'll turn back on because of the NAND. So the output will look like this, but where the width of the output will be determined by the RC constant of the capacitor and resistor in the circuit. So this resistor is R and this is C, and because the circuit will turn off at half, it's when it gets to half, so the time constant of this simple circuit you would expect to be RC times natural log of 2 as delta t of this output, independent of the input. So in the lab, we're actually going to have a circuit that implements this, which is called the CD 4528. It actually has two of these circuits in parallel, and the one thing you need to know about it is that you supply the R and the C, but for this circuit, delta t is just RC. It doesn't have an extra factor of natural log of 2. Another circuit that we should talk about is the LM555 timer chip, and 555 is a 8-pin chip, and as usual with these things, pin 1 is connected to VEE, which we'll take to be ground. Pin 8 is the power chip to determine the voltage. And the important thing about the LMM is the trigger and the threshold pins. Those are input pins, and when the voltage at the trigger goes below 1/3 of VCC, the state of the system on the output will go to plus VCC. In other words, it'll turn on. And when the voltage goes above 2/3 at the threshold input, pin 6, the output will go off. When the output goes off, pin 7 is connected to ground, and when it turns on, pin 7 is just disconnected from anything. and that allows you to change things there. So the way we make a timer out of this, first of all, we connect pin 2 and pin 6 together. They'll have the same input. And we will also, pin 4 we're not going to worry about, but it should be connected to high, which means we're turning off the ability to set pin 3 by hand. We can only set it through pins 2 and 6. And from VCC, then we create a 2 resistor chain, resistor 1, resistor, and that also connects there to the pin 7, pin 2, resistor 2, which connects to pins 2 and 6, and then a capacitor connected to ground. And so in the normal state of things, if we start and say the state of the system is on, so pin 3 is out, 7 is disconnected, then you would expect that current would flow around through R1 and R2, charging up C until the voltage here at this node is above the threshold for pin 6. That's 2/3 VCC. When that happens, we turn off the system and we open up 7 to ground, and therefore whatever charges here can go back out through R2 to ground. And so we're going to charge up the capacitor at a rate e to the minus R1 plus R2 over C, and we're going to discharge it at a rate e to the minus T over R2 times C, not R1 plus R2, because we only discharge through resistor 2. And therefore, the output will go 0 and 1 at a time scale determined by the R1 plus R2C and just R2C for the up parts and the down parts. And so that's how you make a timer out of a 555 chip.